History of Artificial Intelligence Introduction. Artificial intelligence AI is one of the most revolutionary developments in human history. It refers to the creation of machines and computer systems capable of performing tasks that usually require human intelligence, including learning, reasoning, problem solving, decision making, understanding language, and recognizing patterns. Today, AI influences nearly every part of modern life. From smartphones and social media algorithms to self driving cars, medical diagnostics, and scientific research. The journey toward AI has been long and complex. It did not begin with computers in the 20th century but has roots in ancient myths, philosophy, mathematics, and mechanical engineering. Human beings have long dreamed of creating intelligent machines. Over time, advancements in logic, computing, and neuroscience gradually transformed these dreams into reality. The history of AI is marked by cycles of optimism, disappointment, and growth. Early researchers believed intelligent machines would soon rival humans, but technical limitations led to setbacks known as AI winters. Despite these challenges, continuous progress in computing power, algorithms, and data eventually enabled major breakthroughs. Today, AI has entered a new era driven by machine learning, deep learning, and generative AI. Systems can now write essays, generate realistic images, defeat world champions in complex games, and assist scientists in solving biological problems. This essay explores the complete history of AI, tracing its development from ancient ideas and philosophical foundations to modern deep learning systems and future possibilities. Early foundations of artificial intelligence, ancient myths, and mechanical automata. The idea of artificial intelligence predates modern science by thousands of years. Ancient civilizations imagined intelligent machines and artificial beings in myths and legends. In Greek mythology, Hephaestus, the god of blacksmiths and invention, created mechanical servants made of gold. Another myth described Talos, a giant bronze robot that protected the island of Crete. Similar stories appeared in ancient Egyptian, Chinese, and Indian traditions. Although these stories were fictional, they reflected humanity's fascination with creating artificial life. During the Middle Ages and Renaissance, inventors built mechanical devices called automata. These machines could imitate simple human or animal movements. Engineers designed mechanical clocks, automated musical instruments, and moving statues. Leonardo da Vinci created designs for mechanical knights and robotic systems. In the 18th century, inventors developed complex automata capable of writing words or playing instruments. One famous example was the mechanical Turk, a machine that appeared to play chess against humans. Although it was later revealed secretly by a human, it increased public interest in intelligent machines. These early ideas and inventions formed the conceptual foundation for AI by raising an important question: can intelligence be artificially created? Philosophy and logic philosophy played a crucial role in the development of AI. Ancient Greek philosopher Aristotle developed formal logic systems based on rules and reasoning. His work showed that rational thought could be represented through structured processes. Later philosophers such as René Descartes and Thomas Hobbes argued that reasoning might function like a machine. Gottfried Wilhelm Leibniz imagined a universal logical language that could solve arguments mathematically. Leibniz believed that thinking itself could be mechanized. This idea strongly influenced later AI research. In the 19th century, George Boole developed Boolean algebra, a mathematical system for representing logical relationships. Boolean logic later became essential for digital computers. Charles Babbage designed the analytical engine, considered an early concept of programmable computer. Ada Lovelace wrote algorithms for the machine and predicted that computers might someday compose music or create art. Her ideas anticipated modern AI capabilities more than a century before they became reality. Mathematical and computational foundations. The mathematical foundations of AI expanded during the late 19th and 20th centuries. Probability theory, statistics, and formal logic became increasingly important. A major breakthrough occurred in the 1930s when Alan Turing introduced the concept of the Turing machine. Turing demonstrated that a machine could perform any mathematical computation if properly programmed. This idea provided the theoretical basis for modern computers. During World War I, Turing helped break German codes using computational methods. His work demonstrated the power of machines in solving complex problems. In 1950, Turing published the famous paper Computing Machinery and Intelligence. He asked the question, can machines think? And proposed the Turing test. In this test, if a machine could communicate in a way indistinguishable from a human, it could be considered intelligent. Turing's ideas became foundational for the field of AI. Birth of artificial intelligence. The Dartmouth Conference 1956 artificial intelligence officially became a scientific field in 1956 during the Dartmouth Summer Research Project on Artificial Intelligence. The conference was organized by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. John McCarthy coined the term artificial intelligence, defining it as the science and engineering of making intelligent machines. Researchers at the conference believed that significant progress toward human-level intelligence could be achieved within a few decades. The Dartmouth Conference brought together experts from mathematics, psychology, engineering, and computer science. It established AI as an academic discipline and inspired future generations of researchers. Symbolic AI and early programs during the 1950s and 1960s says most AI research focused on symbolic reasoning. This approach represented knowledge using symbols, logical rules, and structured problem-solving methods. Alan Newell and Herbert Simon developed the logic theorist, a program capable of proving mathematical theorems. They later created the General Problem Solver GPS, designed to imitate human reasoning. These programs demonstrated that machines could solve intellectual tasks once thought unique to humans. John McCarthy also developed the Lisp programming language in 1958. Lisp became one of the most influential languages in AI research because it was suitable for symbolic manipulation. Researchers believed that by programming enough rules and logic, machines could eventually achieve general intelligence. Natural language processing and ELIZA researchers also explored natural language processing. In the 1960s, Joseph Weizenbaum developed ELIZA, one of the earliest chatbots. ELIZA simulated a psychotherapist by responding to users with pattern matching techniques. Although ELIZA did not truly understand language, many users felt emotionally connected to it. This demonstrated how humans could attribute intelligence and personality to machines. ELIZA became an important milestone in conversational AI. Early neural networks. While symbolic AI dominated early research, some scientists pursued approaches inspired by the human brain. In 1943, Warren McCulloch and Walter Pitts created mathematical models of artificial neurons. Later, Frank Rosenblatt developed the perceptron, an early neural network capable of learning simple patterns. The perceptron generated excitement because it suggested machines could learn from data and relying entirely on programmed rules. However, neural networks faced criticism in 1969 when Marvin Minsky and Seymour Papert published perceptrons. They showed that early neural networks had major limitations. As a result, interest in neural networks declined for many years. Expansion of AI research. 1960s, 1970s robotics. During the 1960s and 1970s, AI expanded into robotics. Researchers attempted to create machines capable of interacting with the physical world. One important project was Shaky the robot, developed at Stanford Research Institute. Shaky could navigate rooms, avoid obstacles, and follow simple instructions. Although primitive compared to modern robots, Shaky combined perception, planning, and movement. It became an important milestone in robotics research. Expert systems. Another major development was expert systems. Expert systems attempted to capture the knowledge of human specialists in specific fields. Researchers encoded expert knowledge into rule-based systems capable of making decisions. One famous example was mycin, developed in the 1970s to diagnose bacterial infections and recommend antibiotics. Mycin performed surprisingly well and demonstrated the commercial potential of AI. Expert systems were later used in finance, engineering, and medicine. Challenges and limitations. Despite early successes, AI systems struggled with real-world complexity. Symbolic systems required extensive manual programming and lacked common sense understanding. Computers during this era also had limited memory and processing power. Machine translation projects failed to achieve expected results. Researchers realized that replicating human intelligence was much more difficult than initially believed. The first AI winter disappointment in AI progress led to reduced funding during the 1970s. This period became known as AI winter. Governments and investors criticized AI researchers for unrealistic promises. The Lighthill report in the United Kingdom concluded that AI had failed to achieve major practical results. Funding cuts slowed progress significantly. However, some researchers continued working quietly on machine learning, logic, and perception. Revival of AI in the 1980s, rise of expert systems. AI regained popularity during the 1980s due to the commercial success of expert systems. Businesses realized that AI could automate specialized decision-making tasks. Companies used expert systems for inventory management, customer support, medical diagnosis, and financial analysis. The Japanese government launched the fifth generation computer systems project in 1982 to develop advanced intelligent computers. This project encouraged other nations to invest in AI research. Machine learning researchers increasingly recognized that manually encoding knowledge was inefficient. This led to growing interest in machine learning. Machine learning allowed systems to learn patterns directly from data. Statistical approaches such as decision trees and Bayesian networks became popular. Researchers also revisited neural networks. Backpropagation and neural networks. A major breakthrough occurred with the rediscovery of the backpropagation algorithm. Researchers Geoffrey Hinton, David Romelhart, and Ronald Williams demonstrated that multi-layer neural networks could learn complex patterns. Backpropagation enabled neural networks to adjust weights automatically through training. This breakthrough revived interest in neural networks after years of decline. Second AI winter. Despite renewed enthusiasm, AI again faced challenges by the late 1980s. Expert systems were expensive to maintain and difficult to update. Many companies became disappointed with the costs and limitations of AI systems. Specialized AI hardware companies collapsed. This triggered the second AI winter, leading to reduced investment and skepticism. However, research in machine learning and statistics continued to advance. AI in the 1990s. Statistical AI. During the 1990s, AI research shifted strongly towards statistical methods. Researchers realized that uncertainty and probability were essential for dealing with real-world data. Techniques such as hidden Markov models, Bayesian networks, and support vector machines became important. These methods improved speech recognition, handwriting recognition, and natural language processing. The increasing availability of digital data also supports learning research. IBM Deep Blue. One of the most famous events in AI history occurred in 1997 when IBM's Deep Blue defeated world chess champion Garry Kasparov. Chess had long been considered a symbol of human intelligence. Deep Blue analyzed millions of chess positions per second using powerful search algorithms. Kasparov's defeat demonstrated that machines could outperform humans in complex intellectual tasks. The event attracted worldwide attention and increased public interest in AI. Robotics and autonomous systems. Robotics also advanced rapidly during the 1990s. Researchers improved computer vision, navigation systems, and sensors. Autonomous vehicles began appearing in experimental projects. Industrial robots transformed manufacturing by increasing efficiency and reducing labor costs. NASA used AI systems for autonomous navigation in space exploration. Reinforcement learning. Reinforcement learning emerged as a major branch of AI. This approach allows systems to learn by interacting with environments and receiving rewards or penalties. Researchers Richard Sutton and Andrew Barto made major contributions to the field. Reinforcement learning later became essential for game-playing AI and robotics. White, the big data revolution. 2000s growth of the internet. The internet created enormous amounts of digital data. At the same time, computers became faster and more powerful. Graphics processing units (GPUs) enabled rapid parallel computations. Cloud computing allowed companies to process vast amounts of information. These developments created ideal conditions for AI growth. AI in industry. Technology companies began investing heavily in AI. Google used AI to improve search engines and advertisements. Amazon developed recommendation systems for online shopping. Facebook applied AI to social media analysis and image recognition. AI became a major commercial technology. Advances in machine learning. Machine learning algorithms improved dramatically during this period. Researchers developed better techniques for classification, prediction, and pattern recognition. Speech recognition systems became more accurate. AI applications expanded into healthcare, transportation, and finance. Deep Learning Revolution 2010s. Rise of deep learning. The 2010s marked a major turning point in AI history. Deep learning emerged as the dominant approach. Deep learning uses neural networks with many layers capable of learning representations from data. Although neural networks had existed for decades, they became practical only because of large datasets and powerful GPUs. Jeffrey Hinton, Ian LeCun, and Yoshua Bengio became leading figures in deep learning. AlexNet and image recognition. A breakthrough occurred in 2012 when AlexNet won the ImageNet competition. AlexNet radically outperformed other image recognition systems. This success convinced researchers and companies that deep learning was highly effective. Sakiti and deep learning soon revolutionized computer vision. AI systems achieved impressive performance in facial recognition, object detection, and medical imaging. Natural language processing. Deep learning also transformed natural language processing. Word embeddings such as WOR D2VEC allowed machines to understand relationships between words. Recurrent neural networks and long short-term memory networks improved language translation and speech recognition. Companies introduced virtual assistants such as Siri, Alexa, and Google Assistant. Machine translation systems became significantly more accurate. AI in games. This Arco game playing AI achieved spectacular successes. In 2016, DeepMind's AlphaGo defeated world champion Lee Sedol in the game of Go. Go had long been considered too complex for computers. AlphaGo combined deep learning, reinforcement learning, and tree search techniques. Its victory demonstrated the extraordinary potential of modern AI. Later systems such as AlphaZero learned games entirely through self-play. These achievements inspired further research into autonomous learning systems, generative AI, and modern AI 2020s. Transformer architecture. One of the most important breakthroughs in modern AI was the transformer architecture. In 2017, researchers introduced transformers in the paper. The paper Attention is All You Need. Transformers used attention mechanisms to process language more effectively. They quickly became the foundation of modern natural language processing. Large language models too had large language models such as GPT, BERT, PALM, and LLMA demonstrated remarkable abilities. These systems were trained on enormous datasets containing books, articles, websites, and conversations. Large language models can generate essays, answer questions, summarize information, translate languages, and write computer code. Generative AI systems became widely used in education, business, and customer service. AI image generation. Generative AI also transformed visual creativity. Systems such as DAL, Midjourney, and Stable Diffusion can create realistic images from text descriptions. AI-generated art became a global phenomenon. Researchers also developed AI systems capable of generating music, videos, and voice synthesis. These technologies expanded creative possibilities but also raised ethical concerns about copyright and misinformation. AI in science and medicine. AI has become a powerful tool for scientific research. DeepMind's AlphaFold solved the protein folding problem with remarkable accuracy. This breakthrough accelerated biological research and drug discovery. AI systems help scientists analyze massive datasets in astronomy, chemistry, and physics. In medicine, AI assists doctors in detecting diseases, analyzing medical images, and developing personalized treatments. During the COVID-19 pandemic, AI contributed to vaccine research and epidemiological modeling systems. Modern AI has greatly improved robotics and autonomous systems. Self-driving cars use AI for navigation and obstacle detection. Warehouse robots automate logistics operations. Drones use AI for surveillance, agriculture, and delivery services. Humanoid robots capable of walking and interacting with humans gained increasing attention. Ethical and social issues, bias and fairness. AI systems learn from human-generated data. As a result, they can inherit societal biases related to race, gender, or economic inequality. Biased AI systems may produce unfair decisions in hiring, policing, healthcare, or lending. Researchers now emphasize fairness and transparency in AI development. Privacy concerns: AI systems often require enormous amounts of data. This raises concerns about surveillance and privacy. Governments and companies collect large quantities of personal information for AI analysis. Debates continue about how to protect privacy while enabling technological progress. Employment and automation powered by AI may replace certain jobs. Manufacturing, transportation, and customer service industries are particularly affected. However, AI also creates new opportunities in data science, engineering, and technology. The long-term economic impact of AI remains uncertain. AI safety: some experts worry about the risks of highly advanced AI systems. Concerns include autonomous weapons, misinformation, cyber attacks, and loss of human control. Researchers increasingly focus on AI safety and alignment. The goal is to ensure that AI systems act according to human values and ethical principles. Important figures in AI history: Alan Turing. Alan Turing laid the theoretical foundations of computer science and AI. His ideas about computation and machine intelligence remain influential today. John McCarthy coined the term artificial intelligence and helped organize the Dartmouth Conference. He also developed the Lisp programming language. Marvin Minsky co-founded the MIT AI laboratory and contributed to robotics and cognitive science. Jeffrey Hinton played a major role in reviving neural networks and deep learning. He is often called one of the godfathers of AI. Jan LeCun and Joshua Bengio. Jan LeCun contributed to convolutional neural networks and computer vision. Joshua Bengio advanced deep learning and neural language models. Together with Hinton, they received the Turing Award in 2018. Demis Hassabis, co-founder of DeepMind, led projects such as AlphaGo and AlphaFold. His work demonstrated the practical power of reinforcement learning and neural networks. Applications of AI: healthcare: AI assist in diagnosis, medical imaging, and treatment planning. Machine learning systems can detect diseases earlier and improve patient care. Educational AI systems provide personalized learning experiences. Intelligent tutoring systems adapt lessons to individual students. Finance: banks use AI for fraud detection, risk assessment, and algorithmic trading. AI systems analyze large amounts of financial data quickly. Transportation: AI powers navigation systems, self-driving cars, and logistics optimization. Autonomous transportation could improve safety and efficiency. Entertainment: streaming services use AI recommendation systems. AI also contributes to gaming, animation, and digital art. Agriculture: farmers use AI for crop monitoring, soil analysis, and weather prediction. Precision agriculture helps increase food production while reducing waste. Future of artificial intelligence. The future of AI is both exciting and uncertain. Researchers continue pursuing artificial general intelligence (AGI), which refers to machines capable of performing any intellectual task that humans can do. Current AI systems are highly specialized, but rapid progress suggests that future systems may become increasingly versatile. AI could revolutionize medicine, scientific discovery, education, and environmental sustainability. Advanced AI systems may help solve global challenges such as climate change and disease outbreaks. However, the future also depends on ethical governance. Societies must decide how AI should be regulated and controlled. International cooperation may become essential for ensuring responsible AI development. Some experts envision humans and AI working together to enhance creativity and productivity. Others warn about risks associated with uncontrolled AI systems. The debate about AI's future will continue shaping politics, economics, and culture throughout the 21st century. Conclusion: the history of artificial intelligence is a remarkable story of imagination, innovation, setbacks, and transformation. From ancient myths about mechanical beings to modern generative AI systems, humanity has long dreamed of creating intelligent machines. Philosophers, mathematicians, engineers, and computer scientists gradually turned these dreams into reality. Early pioneers such as Alan Turing and John McCarthy established the foundations of AI research. Later advances in machine learning, neural networks, robotics, and deep learning transformed AI into one of the most important technologies in the world. Today, AI influences healthcare, education, transportation, finance, entertainment, and scientific discovery. At the same time, AI raises major ethical social questions about privacy, bias, employment, and safety. The story of AI is still unfolding. Future generations may witness machines with capabilities far beyond those of current systems. Whether AI becomes humanity's greatest tool or one of its greatest challenges will depend on how wisely society develops and governs this technology. In many ways, the history of AI reflects humanity's broader quest to understand intelligence itself. By attempting to create intelligent machines, humans continue learning more about reasoning, creativity, consciousness, and the nature of the human mind. Artificial intelligence is therefore not only a technological revolution but also one of the most important intellectual journeys in human history.